All right, so I just took a look at problem 3. Gonna take a little second, but it asks us to write TC201. No, TC201. What's it called? Yeah, TC201. All mixed up. That takes a number n and prints out first n odd positive integers, right? And the example they give is like 4 is the input, and it'll print out 1, 3, 5, 7. Okay, so we just gotta add 2 every time. Probably have to have 1 in data somewhere so that we can add 2 to it. We output those numbers, we have to store them back somewhere. It seems fairly straightforward as for a TC201, I think. This is really a test of if I remember how to write TC201s. So we have a list of instructions. Here's like my first instruction. Let's make it input 0. So we get that input from the user. Let's store that value in data. So then we're going to have our 4 somewhere down here. What are the parameters for our input? It says it's just n, any n, I guess. So it could be 0. So how about here? I have skip 0. Remember, skip 0 doesn't need to take any input. I'm just passing it a 0. And if I have a 0 here in my accumulator, storing it, remember, doesn't affect what's in the accumulator. If I have a 0 here, I'm going to skip to something that jumps to end, figure out what end is later. If I don't have a 0 here, actually, if I have a 0, why don't I just halt? I don't think I have to do anything after my number is 0. Yeah, let's just try halting here and see if that gives us any problems. Halt at 0. Here we're going to jump to, we'll just say next. And the next will be down here. At next, we're going to output the next number. So I'll say load from, let's say, x. I don't know. Let's name it something more descriptive. Odd int. I'll say add const 2. Then I'll say, it doesn't really matter the order of a couple of these, but I'll say output 0, store odd int. Right, so it'll say, load our number, it starts as 1, out. Oh, maybe I don't want to add constant 2 before I output, because then I would have to start with this number as negative. I want to output first and then add the constant 2 to it. Output 0, add const 2, then store it. So take 1, output, it'll add 2, get 3, and put that back into somewhere down here. And then after it stores it, I just need it to jump. Oh, now I need it to decrease my input, my data, by 1. So I'll say load data sub 1 store data. And then jump, let's go here. Okay, and I need a couple other things. I need data 0. Oh, I shouldn't call something data, because data is like a real thing, isn't it? We'll call this x. So x data 0. I need odd int, and I need const 2. And I also need, don't I need 1? Yeah. Odd int, const 2, and 1. Oh, this is a little bit bad. Odd int data 0, const 2 data 2, and then I have odd int, I have const 2, and I need 1. 1, data 1, close that. Close my list from the top. Okay, I think this works. I hope it works. I think the general idea should be pretty easy here. It's just, some syntactical stuff. Maybe I messed up. They pass in an odd number for n. I'm not sure what I'm supposed to do. Maybe here I say, can I use skip pause to be kind of clever? Because I don't know what skip pause does on 0. Maybe you could modify this a little bit to take into account negative numbers if you really wanted to. I'm a little bit lazy. I guess this will infinite loop if it gets a negative number. I should probably fix it. I guess I would fix it by something like remembering if skip pause checks, or what skip pause does till the number is 0. And then once I remember that, I can use skip pause to figure out when this reaches the number 0. Or if it's below the number 0, it'll already skip and just halt already. But just pretend I did that. Okay, and then we're going to move on to 3b. Did I mess up something? Oh shoot. I was like looking at the next problem and I realized I did some silly stuff. So I have another data here that I didn't really have in a line down here. This data I want it to be, well, I'll have my audience starting as 1. This data should be x. Okay, there we go. I think that fixed it. I have, yeah, okay. 3b. What is the largest value of n for which we could expect to have a TC201 output the first n positive integers, n odd positive integers in increasing order? Exponential notation is fine, please justify. Oh geez, okay. So we want to output the first n odd positive integers. So what's the largest number we can output? Well, it's going to be, we have 16-bit notation, so it's going to be a 0 followed by 15 ones. So it's going to be like 2 to the 15 minus 1, right? If we had like 1, 1, this is 2 to the 2 minus 1, because this is 3. 2 to the 2 is 4. 4 minus 1 is 3. So 2 digits is 2 to the 2 minus 1. 15 digits is 2 to the 15 minus 1 is the biggest number we can output. But if we want to output the first n positive, odd positive integers, that's going to take us to larger than n. So like here the first n positive integers go up to, what is that, 2n minus 1. We have to be able to output. I think that holds true. If this were 5, it would be 9. So and if I want to go to 2n minus 1, what's the largest n can be? Well, I want 2n minus 1 to be equal to this. So that means 2n equals 2 to the 15, and I guess n then equals 2 to the 15 over 2, which is 2 to the 14. About text. Great, okay, I hope that worked out. Made sense? And 3c. Could there exist a racket program that takes as input a configuration config and correctly decides whether starting in config the machine will eventually reach a configuration with the run flag equal to 0? Assume that the user types in 0 in response to every input instruction. Okay, so this is another sort of variation of the halting thing that we've been thinking about earlier. Right, in relation to Turing machines and other stuff, gates. The main idea here is that a TC201 actually does have finite configurations, just like gates have finite configurations. Circuits have finite configurations. Turing machines are like theoretical, they don't. They go off infinite in every direction. This has a finite number of configurations because our program counter, if you remember the CPU we defined with an ACC, a PC, an RF, and an AEB. The program counter only has so many, it has 12 digits, right? So we can't represent a configuration that has, our RAM cannot be greater than, I guess, 2 to the 12 minus 1 instructions, right? So even though it's a really, really big number of potential configurations, it's a finite number of potential configurations. So we can write something that will start at the beginning and keep looping through them until it reaches one that it's seen before. It's important that they mention, that the user always inputs 0, because if the user input different things, then we could, actually I guess we would still eventually maybe reach a configuration we've seen before, but the point is that we are able to detect whether this is in a loop or whether it actually reaches a state where the run flag is 0, because finite number of configurations that we're going through. And I think that's all of 3. I will see you in 4.